This is a continuation of some concepts we learned in the previous class. In it, we took a look at about 4 functions: sum, average, max, and min. We're going to add a financial function today, payment. If we wish to calculate a payment, there's a couple of different ways you can do it. The shortcut way is to simply type in equal followed by the function name. You then get a tooltip that tells you what to enter. The first thing is rate. In this case, I have rate in B5, comma. The number of periods is the number of payment periods, the term in other words, so 3 years, comma. PV is the present value of the loan, and that's $9,999. We can finish it off with the parentheses, and we find that if we want to buy a $10,000 car, 3 years at 7% interest, we would be paying $3,800 a month. Hopefully that strikes you as a little odd, and it is. However, take $3,800 and multiply it by 3, and you do get something a little over $10,000, don't you? That's because this is the yearly payment. Let's take a look at the equation again. If I have a 7% interest rate, what is the rate per month? You have to divide it by 12. Likewise, how many payments am I going to be making if it's monthly? It's the number of years times 12. I don't want to hard code a 36 there, because if I decide to try a longer period, 4 years, 5 years, then I would have to change it in the formula. Enter. $308.74. That's the correct answer. Now take a look at that. It does look a little weird, right? Because it's in red and in parentheses. What does that mean? It means it's negative. If I were to format this as accounting or something, it might take away the red, but it would still be in parentheses. It would still be a negative number. We basically need to multiply the result by a -1 in order to turn it into positive. You could simply put in times -1. And now we have a positive number. That's one solution. Another solution is to put a minus sign in between the equal and the PMT. That is a little difficult to see sometimes. So it's not my favorite, but I never count it wrong. Here's what the accounting type people do. They put a minus sign in front of the loan amount in the formula. That is typically how they do it. The 3 cells in column B are called assumptions. I can change those. I can change the number of years to 5 and find out what the monthly payment would be. I can change any of those 3 numbers and it works. I will, however, reset it back to the first one. What if we wanted to try out a range of several things? Maybe I'd like to see what the monthly payments would be for a range of 5 to 8%. I could type in 5%, and then, if we go up by 0.5%, 5.5%, I can then highlight both of them. I do need to highlight both of them. And it comes up with a sequence. So to review again how we did that, we highlighted the 2 that showed the pattern and then grabbed the copy fill handle. Now I can put in my payment function again. the rate divided by 12, comma, the term times 12, comma, and negative the loan amount in B3. But what happens when I copy that down? I do get something rather strange, very bogus results. What would your first reaction be? Oh, click undo? No, that's not the answer. The correct response is, go take a look at one of the bad formulas and see what it did. So if we look at the formula here for the 5.5%, the rate is A10. Well, that's correct. But the term is in B5. Oh, that's not correct. And the loan amount is in B4. That's not correct. Going down to the next one, the rate is in A11. That's correct. The term is in B6. No, that's not right. And the loan amount is in B5. That's not right. What happened is the idea of relative addressing. As we copied it down, it kept the same format of 4 away and 3 away, and it just kept copying that down. We know from Chapter 3 that we need to use absolute addressing for this to change. So, clicking in the formula, we know that the A9 changing to A10, etc. was okay, but the B4 needs to stay locked down at B4. You can press function key F4 and it will type in the dollar signs for you. So both the B4 and the B3 need to be locked down. So take a look at that formula. And when we copy it down, we get much more rational results. Now, I could make this a little bit more adjustable. Instead of hard coding the 5% here, what could I do? I could code in the starting rate that's in B5 by going equal B5. So if I change the item in B5 to some other value, it will change there. But to get the amounts to change underneath it, I'm going to need a formula. Equals A9 plus 0.5%. If I copy that formula down, I now have percentages that will change when I change the value in the assumption area. There are two other functions that we can add, and they are date and time functions. One of them is equal now, left parentheses, right parentheses. The other one is equal today, left parentheses, right parentheses. I'd like to contrast those with putting in today's date, 01/29/2008. What are the differences here? For today's date, when I show the formulas, I see that today's date is 39,476. What is that? Well, that's the number of days since January 1st, 1900. Only the original person who figured out these functions didn't know that 1900 was not a leap year. And so 1900 has a February 29th in both Excel and Lotus 123. Somewhat erroneously, we might add. If I come up to the function that says equal today, and press function key F2 and then function key F9. Function key F2 followed by function key F9 will change any formula into the hard-coded answer. You can see that it is using the same process, the number of days. This concludes the module on the payment function. This is further preparation for chapters 3 and 4 of Excel. Hope you had a good time.